derive the quantity of current flowing in the RL circuit shown. So let us traverse this circuit in a clockwise direction. Let's start from this point A and move this way and back to A. If we cross this seat of EMF, the potential drop is E. The switch is closed. On crossing R, the potential drop is IR. On crossing L, the potential drop is L di over dt. You come back to where you started, it's equal to 0. We can, from here, see that E minus IR is equal to L di over dt. We can divide both sides with L, so that we'll be left with di over dt is equal to E minus IR all over L. If we cross multiply, if we break this one up and break this one down, we will have di over E minus IR is equal to dt over L. So we integrate both sides. X equal to E minus IR. That means that the X over the I is equal to 0 minus R, equal to minus R. So we come here now and see that this equation becomes di over X, which is equal to, if you like, dx over x times di over dx. We made some transformation, so that if this one divides this, you will still get back this. So this one is equal to 1 over L dt. If we integrate this one, you have it to be log x, and this one already is 1 over r minus 1 over r. The x over the I is that, so that one will be minus 1 over r is equal to t over L plus constant of integration. In order to find the value of the constant of integration, we say at t is equal to 0, there's no current flowing. Therefore, k is equal to, this is 0, minus log x over r, and x is equal to E minus IR. So, and I is 0, so it's just minus log E over R. We put it back into equation 1, and we have log, remember x is E minus IR over R, that's minus here, is equal to T over L plus minus if we multiply through by r, we'll get minus log e minus ir for this one. This one will be is equal to r over l times time minus plus is minus log e. From here we can bring this one over here, or bring this one over here and bring this one over here. So you see that minus r over l times time is equal to minus log e plus log e minus ir is equal to minus r over l times time. This one is equal to, using division law of logarithm, you see that this is plus, this is minus this. You have log e minus ir over e. Therefore, e minus ir over e is equal to exponential minus rt over l. E minus ir is equal to e exponential minus r over l times t. We have that e minus e exponential minus r l times time is equal to ir. Ir is equal to the voltage in the inductor. The current in the inductor can be derived from here. So you see that I is equal to e over r into 1 minus exponential minus rl t. From these two equations, the voltage in the inductor VL and the current in the inductor IL, if you like, you see that at t is equal to 0, I is equal to 0. At t is equal to infinity, at t is equal to infinity, IL becomes e over r into 1 minus exponential minus infinity, and this is 0, so we have it to be e over r, so it reaches its maximum value at infinity, whereas this one is e over r into 1 minus exponential minus 0. This guy is 1, so that's why we got it to be 0. That means that if we plot a graph of a v against time, it will decay exponentially like this, starting from e and going down. This is a tau, time constant. Time constant for an inductor is L over R. Tau. Whereas the current I, this is voltage VL, this is IL. So the current will be 0 at I is equal to 0 and maximum at infinity, if you like. So you have something like this. So this is a graph of e exponential minus RL times time, R over L times time, whereas this is the graph of IL is equal to E over R, that's this one, into 1 minus exponential minus R over L times time. These are time constants. Time. This is tau, 2 tau, 3 tau, and so forth and so on. The first time constant will be, if you use this, it will be IL is equal to E over R into 1 minus exponential minus R over L times L over R. That's tau. We are replacing the T now with tau. So you have it to be E over R into 1 minus exponential minus 1. That means 0.63 I max. And this I max is 0.63. I max is E over R. That's what we have gotten it, because here it will be E over R. That's the I max here. So that is for this, we'll be using this. It will give us V, if you like, of the doctor is exponential E exponential minus R over L times L over R. So it's E exponential minus 1. So it's 0.37 E, or 0.37, the maximum value, the initial value of the voltage. So that is how to do it. Kindly subscribe, like the video, and click on the notification button so that when another video comes up, you see it. Bye.